Today we will see permutation and combination, right? Permutation and combination. Here, the term permutation and combination means how it can be differ, or what is the meaning for permutation and combination. We can simply verify this one using some example, right? Say fundamental principle of counting. The fundamental principle of counting. What's the principle of counting? If an event can occur in m different ways, so one event can occur m different ways, following which another event can occur in n different ways. Then, so one event is happen m different ways, another event is happen n different ways. These two events are mutually exclusive, no more interrelationship between these two events. Then the total number of events occur, the possibilities of event, we can multiply m with n, right? We can multiply m with n. So actually, if we can see this things using the definition, it's a little bit tough, right? So I think a better way we can see using some examples. So Rohan has 3 shirts and 2 pants, right? In how many ways? In how many ways combinations are possible, right? In how many are the combinations possible? How many ways we can choose 3 shirts and 2 pants? Here, I have 3 chances to select the shirt. I have 3 options. Option A, pink color. Option B, white color. Option C, gray color. I can choose these 3 different shirts in my preference, in my options. I can choose these 3 different shirts, whatever I wish to search or select one. I have 2 more options. I can choose 2 pants, right? I can choose 1 blue pants or 1 white color pants. Totally, out of these 5 different categories, I can choose 6 different dresses or 6 different ways we can dress the t-shirt and trouser. Could you understand what I say? Here, 3 shirts is available, 2 pants is available. If I can choose 1 pink shirt, I have 2 options. I can wear blue or pant or white pant. So in this pink shirt, I have 2 different style of dressing, right? Pink and blue, pink and white, 2 different ways of dressing. If I can choose white shirt and blue trouser, white shirt and white trouser. So I have 2 more different dressing. If I can choose gray t-shirt, gray and blue, or gray and white, 2 more options. Totally, each and every selection of shirt, I have 2 pant selection. So 3 into 2 different ways of dressing. Totally, I can dress up 6 different ways, right? So this is the thing. The definition says we can choose 1 event is happen m different way, that is 3 shirts. Another event is happen n different ways, that is 2. So the number of possible combination, it may be m into n, 3 into 6, that is equal to 6 different ways of possible outcomes is available, right? So permutation actually, so don't think about what is the meaning of permutation. I think in your class grade 8, 9, 10, in between this 8 to 10, definitely you studied what is permutation, what is combination, right? Why we are studying permutation and combination. If you want to choose any field or any variety, how many different ways you can select these things, right? So in the field, you have different field. So you have different plots. How many different ways you can arrange these things, right? Okay. In the permutation, actual meaning for the permutation is in Tamil. I don't know the words in Sinhala. So the word is varisai mattam. Combination means sermanam. Varisai mattamum, sermanamum. I think each and every student already had a good knowledge about the permutation and combination. In this class, we can revise what's the exact contents of permutation and combination. Say a way. Definition: a permutation is an arrangement. Is a definite order of number of objects taken, some or all at a time, right? We can choose something from the total number, or we can choose all the numbers to arrange the orders. Say permutation, if we are talking about order, the ordered arrangement, if you can consider the order, so that is permutation. If you forget about the order is nothing, order is no more. We are not considering the order, it goes to combination. So two things, one is permutation, second one is combination. If you consider the ordered arrangement, it goes to permutation. If you are not worried about the ordered arrangement, it goes to combination, right? No problem. Say, what do you mean by the term permutation? In theoretical notation or in mathematical formula, the permutation can be denoted by NPR. P denoted by permutation, N, say total number of events happen, that is the N. R is we are choosing R event. So the bigger number is N, R is the smaller number. So the R is moving from 0 to N, right? R goes to 0 to N. Say NPR, normally we factorial over N minus R factorial. Coming this example, I can illustrate to you how this formula came, right? So example, first thing, how many different signals can be made by 3 flags from 4 flags of different colors? We have 4 flags. We have 4 different flags, right? We have 4 different flags. Using these 4 different flags, at a time, you can choose 3 different flags only. You have 4 different flags. At a time, you can choose 3 different flags. So, choose 3 flags. How many different signals you can produce? So, in this example, is it an ordered arrangement or not? What do you feel? Is it an ordered arrangement or not? If it is an ordered arrangement, then it goes to permutation. It's not an ordered arrangement, it goes to combination. So first we can simply understand it is permutation question or combination question. What do you feel? It's ordered arrangement question or not worry about the ordered arrangement? Ordered arrangement. Why it's an ordered arrangement? Because out of these 4 flags have 4 different colors, right? We can arrange the flag whatever the color is available. Then the color coding says each and every arrangement should be 1 different signals, right? Using these 3 colors, we can produce different signals. So it definitely goes to ordered arrangement, because each and every 3 flag arrangement produce one distinct signal, right? So due to that, it's an ordered arrangement. So in this ordered arrangement, we can have 4 flags. Out of these 4 flags, I can choose 3, right? I can choose 3. Then in this formula, we can simply go to apply this one in the formula. So we have 4 factorial upon n minus r factorial, the NPR. NPR is equal to n factorial upon n minus r factorial. N is equal to 4, so 4 factorial upon 4 minus 3 factorial, that is equal to 1 factorial. How many of you vigilance for the factorial, the exclamation mark? The exclamation mark says factorial, right? Exclamation mark says factorial. I think some of the so 10 factorial means 1, 2, 3 up to 10. Each and every number should be multiplied inside, right? So actually we have 4 ways, 4 different flags. So we can choose 4 ways. If you can choose 3, you can choose 2. Here in this example, we can use these things using the formula. Say how we can get the results. Say I have 4 different flags. In the first box, we can choose. Second box, we can choose. Third box, we can choose. I have 3 boxes. Right? I have 3 boxes. I have 4 flags. Right? So in the first box, I can fill. How many different flags I can fill? How many different ways I can fill the first box? I have 4 flags. How many different ways I can fill the first box? 4 ways. Because 4 flags is available. I can choose 3 flags at a time. Right? So 3 flags at a time, I can imagine or think 3 boxes is available, right? We can fill each and every box using these flags, right? First I can choose 1 flag out of these 4 flags. So I have 4 chances. I can choose the first flag, I can choose the second flag, I can choose the third or fourth, right? So in the first box, I can fill the flags using 4 different ways, right? So I can simply fill the first box using 4 different ways. So I can already fill the first box, right? I already filled it up with the first box. So how many flags is remaining? How many flags is remaining? Already 1 flag is chosen. So now I have only 3 flags because first flag is already occupied. I already used, or I already allocate, right? So due to that, I have no option to use the same flag again and again, right? So due to that, I can choose to fill the second flag using only 3 different ways, right? I can choose to fill the second box only 3 different ways. Why? Already 1 flag is allocated to the first box, right? So the second flag is also allocated in the second box. Then how many flags is available to choose? First box already filled by 1. Second box already filled by the second one. Now I have only 2 flags remaining, right? So I can choose to fill the third box using only 2 flags. So the first box we can fill 4 different ways. Each and every selection of the first box, I can choose to fill the second box 3 different ways. Each and every first and second box selection, I can use to fill the third box 2 different ways. So how many different ways is possible? Then we can multiply. Why we are not adding these 3? Each and every selection of first one, we have 3 different second one. So we can multiply each and everything. So 4 into 3 into 2, 24 ways. This is the thing illustrated in the example, in the formula. We can simply put the formula, we can get the result, right? In this case, up to now, when we are using a flag, we are not using the same flag again. The repetition is prohibited, right? Repetition is not allowed. When we are allowed to do the thing using the repetition, when we are allowing the repetition, what's happened? The number of permutation n different objects taken r at a time, repetition is allowed. A repetition is allowed. So at a time we can choose 3 flags and replace the 3 flags, then we can choose it again 3 flags. In this case, we can use the same number of flags again and again. So if it is 3, 3 into 3 into 3. If it is 4, 4 into 4 into 4 into 4. N to the power r, right? N to the power r. Say, next question. How many 3-letter words with or without meaning can be formed by word nuts? Not nuts, N-U-T-S. When repetition is allowed. When repetition is allowed. So the repetition is allowed in the letter N-U-T-S. I can use the first letter out of N-U-T-S. How many different ways is possible to select one letter from N-U-T-S? How many different ways? How many different ways I can choose the first letter out of N-U-T-S? How many different ways? Because we have only 4 letters. So we can choose 4 different ways for the first letter. If I can use the letter anyone, N, O, U, O, T, O, S, and then simply replace the letter inside the box. So now remaining 4 letters is available. I can choose the second letter. How many different ways I can choose the second letter? With replacement. With replacement. First letter I can choose, found the letter, put it again. Remaining 4 letters is available. I can choose the second letter out of the 4 letters. How many different possibilities is available to choose the second one? N, U, T, S is available. So now also we have 4 different ways. So each and every selection of the first letter, I have choose the second letter. Do the same, do the similar. We can choose the third one is also 4 letters, right? So what's the possible arrangement is available? 4 into 4 into 4. Here in this example, we can use the letters using repetition. Letter can be repeated. First letter N is possible. Second letter N is possible. Third letter also N is possible, right? We can repeat the same letter. That means if I can choose the letter, observe the letter. Is it okay? Say, how many 3-letter words with or without meaning can be formed by words nuts when repetition is allowed? N is equal to 4, R is equal to 3, then the result is 4 to the power 3, 64 words. Theorem 3, the number of permutation of n object where P1 object are of one kind, P2 object are of the second kind, Pk objects are the kth kind, right? So in the first example, we can choose the flags but not put it again. So if it is choose, that's all. No more repetition. Second theorem says if you can put it again, if it is repeated. Third one, we are not putting it again, but the same flag, same marble, same ball come again and again, or same letter come again. Something is repeated, right? That is the theorem 3. Here, find the number of permutation of word A, L, L, A, H, A, B, A, D, alphabet, right? Say here, in this word, how many different numbers A, L, L, A, H, A, B, A, D, right? Total number 9, right? Using these 9 letters, consider, first you can consider each and every letters are distinct letters. Each and every letters are distinct letters. That means A is distinct, L is distinct, another L is also distinct. Here, side by side 2 L is available, or in this letter, some A are repeated, some L are repeated. So you can choose, or you can assume each and every letters are distinct. So A1, A2, A3, each and every letters are distinct. What's the different possibilities is available to choose all the letters at once? If we can choose 9 letters, how many different permutation is available? Because this one is ordered arrangement. If it is in an ordered arrangement, it can be automatically goes to permutation, right? So in this permutation, so we can assume there are 9 letters, there are 9 boxes is available. How many different ways we can choose the first box, choosing from the 9 letters? Here, that's why I assume each and every letters are distinct. First, you can assume all the letters are different letters, not right. All the letters are different letters. So then, the first box can be filled using these 9 letters, 9 different ways. How many different ways is possible? Right? If you can choose the first box using 1 letter, right? Already used to occupy the first letter, how many different ways is possible to fill the second letter? In this case, normally the repetition is not allowed. If they are saying the repetition is allowed, then only you have to think about repetition. Otherwise, no more repetition. So the first letter already occupied. How many different ways is possible? 9 ways, right? 9 ways. So out of these 9 ways, the first one, second letter. Your answer is expected. How many different ways we can choose to fill the second letter? Totally 9 boxes is available, 9 letter is available. So every letter we can assume every letter is a distinguish. Distinguish means every letters are different, right? How many different we can choose the second letter? 8. Why 8? Total 9 letter. 9 letters are distinct. So now already use the first letter. So remaining 8 letter is possible. How many different ways we can fill the second letter? 8. How many different ways we can fill the third letter? 7. And so on up to 6, 5, 4, 3, 2 into 1. Totally 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. 9 factorial different ways we can choose to fill this letter. All are distinct. All are different letter. Then we can choose to fill out this 9 different ways. Are you agree? All the letters are different. Then the total different ways of selection is 9 factorial. But in this case, A is repeated thrice. 1, 2, 3, 4, 4 times. A is repeated 4 times. L is repeated 2 times. So, what do you mean? Out of these 9 letters can be arranged, remaining the meaning same. It's create the meaning same. 2 letter L, if you can put that is in the second position or third position, both are same. Second and third or third and second, both are same. So here some letters are repeated, it creates the same pattern. All are distinct letters, then the total numbers 9 factorial. But out of these 9 letters, 4 A is repeated. So if I am choosing 1 A in the first location, 1 A in the first location, then I can't allow to choose the second A in the first location or third A in the first location. So due to that, the letter is repeated again and again. So the letter is repeated again and again. So if you want to avoid the situation, we can use to divide the number of repetition pattern using the same letters. So here, n factorial upon A is repeated 4 times, we can divide 4 factorial. L is repeated twice, we can divide the 2 factorial. So the 9 factorial, the number is little bit more. If you can choose 3 letters, out of that 3, 2 is same, then we can try to explain the matter using a small exercise, right? Could you capture this contents, or if you have any problem to capture it? On how can we deviate? This one is permutation or combination, is it? No, actually the question based on order, then is permutation. If the question is not in the order, it automatically goes to combination. Say the letter of arrangement. The letter of arrangement. We can arrange the letters by order, no? We can arrange the letters by order. So then it automatically goes to permutation. So I will explain that the thing using the example. Then only you can easily wrap out this one is order or not order. So in the 4th year students, we can choose out of 70 or 75 students, we can choose 3 students for the junior. So one is the president, another one is the secretary, third one is the treasurer. So how many different ways I can choose the president out of the 75 students? How many different ways is possible?
75.
75. Because if he can choose the first one, Azan, he is the president. So how many different ways we can choose the secretary out of these 74? Because already one is occupied the president. So remaining 74 is available. How many different ways we can choose the second one?
24.
74. Do the same, treasurer goes to 73. Is it ordered arrangement or not? Ordered arrangement, then you can arrange president is the first, secretary is the second, treasurer is the third. If you are not considering the ordered arrangement, then it goes to combination. Say in your class, we can choose four males and 3 females to form a special team, right? We wish to form a special team. Our purpose is form a team, right? So we can choose 4 students out of 30 male students. We can choose 3 female students out of 20 female students. Now we can form 4 plus 3, 4 male and 3 female students to form a team. If you choose the student, if you consider the order, or no, don't worry about the order. What do you feel? In the team, if you are forming a team, if you are thinking about the order or not, no need to think about the order for forming a team, because we can choose forget about the females also. So only 10 members is available. We can choose 4 members, right? 4 members. Select 4 members to form a team. No more captain, no more vice captain, nothing. Only 4 members form a team. Right? First one is selected, second one is selected, third one is selected, fourth one is selected. Now there are 4 members selected for this team. This is my team, right? This is my team. So 4 players, only 4 players, they are playing the game. We are not worried about the order, because the person A is selected first time, and we can arrange the rest of them within this team, no point of view, because all of them are players, they are playing the game. In this type of question, we are not worried about the order. Could you understand what I say? Question is based on order, then only it goes to permutation. No need to worry about the order, then only it goes to combination. Actually, I couldn't give the, up to now, I couldn't give the combination formula and all, but everything is in an ordered arrangement. We think about the order, then only that goes to permutation. So it's nothing about the order, only formulation of team. So we try to form a team, that's all. Why we are worried about the order inside the team? No more. So then it automatically goes to combination. Is it clear? So sometimes it may be blurred up to now. So no problem. We can try to make practice. It's make what's the ordered arrangement, what's okay.